Hello and welcome to yet another video of Cornerstones of Math. So this video is inspired from my last video, which you can check from the link in the description or at the top right corner. In my last video, I have obtained an expression which contains this. n plus 1 n squared plus n plus 2, n to the power 4 plus 2n cubed plus 3n squared plus 2n plus 8. And it occurred to me, hey, how about making an inequality out of this? Of course, there may exist other things to do with this expression. For example, you could make a religion out of this. But in this video, I will make an inequality out of this. And that is today's problem. So now the x is real number, and you have to solve the inequality x plus 1 times x squared plus x plus 2 times x to the power 4 plus 2x cubed plus 3x squared plus 2x plus 8 less than 0. Now let's review some fundamentals here. The basic principle of finding the solution of the inequality is to think about the graph of the given function. Like in this example. Therefore, we must find the shape of the graph of this function. But how do we do that in this OCTIC function? Should we use calculus? Well, in fact, we will attempt to solve this problem without using calculus. The first hint comes from this quadratic term, x squared plus x plus 2. Here we can find out one useful properties of this term, and that is, we will claim that this x squared plus x plus 2 is always positive for all real numbers x. And this is really easy to prove. We simply convert into the vertex form of the quadratic function. So in order to complete the square, we write 1/2 squared here, and the remaining constant term should be 7 over 4. So this part is complete squared, x plus 1/2 squared. So we have x plus 1/2 squared plus 7 over 4. And since this part is non-negative, this entire thing is positive. This means that x squared plus x plus 2 does not affect the overall sign of the left-hand side, since it's always positive. So we wonder, can we say the same thing with the quartic expression? And that would be my next claim. So my second claim is that this quartic expression is also positive for all real numbers x. Now how can we prove this? Again, you can use calculus to prove this, but I will not use calculus here. The trick here is to manipulate the expression a little bit so we can use the substitution, which means that we split this 3x squared into plus x squared and plus 2x squared. Then this part becomes the complete square, which is x squared plus x squared, and this part can be written as 2 times x squared plus x. So we have this, so we can use the substitution and let x squared plus x as t. Then we have t squared plus 2t plus 8, which is t plus 1 squared plus 7. And since this part is non-negative, the entire thing is positive. And this concludes the proof. Therefore, this quartic term does not affect the sign of the left-hand side as well. It is also always positive. Therefore, the only terms that change signs are this x plus 1. Now note that the left-hand side becomes 0 when x equals 0 or x equals minus 1. So the graph may look something like this, passing through minus 1, 0 and 0, 0. Or we can divide both sides with this, since they are all positive and therefore do not affect the direction of the inequality sign when divided. This leaves x plus 1 less than 0. In either way, we obtain the solution. X is greater than minus 1 and less than 0. I was genuinely pleased to find out that the given OCTIC polynomial inequality gives such a simple solution, owing to the fact that two big factors turned out to be always positive. And that's all for today's video. Thank you all for watching, and I will see you in another video.